Hello my dear students, this is Akash SD. Welcome to the SG Physics classes students. Hope so you all are doing really great. So students, in this video we are going to solve the question from the topic Doppler's effect in the chapter waves. So in Doppler's effect, what happens that whenever there is relative motion between the source and the observer, then the frequency received by the observer is different from the source frequency. This effect is called what? This effect is called the Doppler's effect. Okay, so let's go through the question and let's see in a detail. So see, a person driving a car at a constant speed of 15 meters per second is approaching a vertical wall. The person notices a change of 40 Hz in the frequency of his car horns upon reflection from the wall. The frequency of the horn is how much? Okay, so students, here remember that the situation is what? This is the wall is there. Okay, this is the wall now, and here one car driver is there. Now car driver is there. Okay, so here remember that here two things are there. One is the observer inside, and here itself source is also there. Na? From source, what is this? Some horn is coming. Observer and source at the same place. Why? Because driver is inside the car. Okay. So in this situation, what is happening that? What is the frequency of the source? The frequency of the source, student, that means the frequency of the horn. How much? It has given here the frequency of the horn. No, not given. No? That we have to calculate is there. Okay. After that, what is this? The frequency received by the driver is having how much difference? A change of 40 Hz. You know very well when the car will move towards the wall. So in this situation, by the common sense also we can tell very well the frequency will increase. Okay. So here what will happen that here his observed frequency how much here? F plus 40. Now F is their source, but when he is receiving 40 Hz change is there, that means F dash we can write here F plus 40. Okay. And after that, what is the speed of the source? That means horn is there na, inside this one na, car. So Vs how much is given here? Remember that here 15 meters per second. Okay, and even we can tell very well velocity of the observer also same 15 meters per second. That means horn, driver all are inside. Can you see very well? Okay, and what we have to calculate here? We have to calculate here F. So students, here in this kind of situation where source and observer at the same point and the object is moving towards the wall. So here we have to apply little bit shortcut, and here the shortcut is just like a mirror concept. So here the wall will just become like a mirror. Okay, and here what will happen that here? Remember that here this is the car, and here inside observer is there. Okay, and he is going to receive the frequency F dash. Okay, then where is the source? The source will come here. Okay, just like a mirror. Now this is the source, and remember that here this source is going in this direction with Vs. Observer in this direction how much here? V0. Source is coming this side Vs, and here what is this? Is some horn is there. Okay, just a shortcut, just shortcut, is it? So you can see very well. Now we have just a vertical wall we have considered as a mirror, and like this we have done is there. Okay, so after that students, if I write here the some formulas, the formula is that here, remember that here the frequency received by the observer is always given by, remember that here it is given by V minus V0 by V minus Vs. This is a general formula into F. This F is the original frequency, F dash is the apparent frequency that is received by the car driver. Okay, but here then we have to apply here the sign convention. The sign convention, remember that here source to observer it is always taken positive. Source to observer positive. So observer to source it will be how much here? Negative. Now this sign convention we will always follow. So based upon that we'll put here the values. So remember that here students this is F, and here kindly say very well this is the V minus velocity of the observer. Velocity of the observer this side, right side, and right side is what? Minus. That means I will write here minus. How much is there? We'll write here minus. Anything you can write here. See whether source frequency, observer frequency same only na. So anything we can write here. I have written here the minus Vs. Okay, minus Vs na. V0 this side, so we can write here minus Vs, or even if you wish you can write here V0 also, no problem na, because both are same only. After that what will happen that here V minus source is coming this side, the source is coming this side, that means what is this? Plus. Okay, so we can write here as it is plus, is it? So you can see students very well. Now this F dash will come here what? F, and it will come here, you can see very well V plus Vs by V minus Vs. Kindly see very well, this formula is very, very important. F dash equal to F V plus Vs by V minus Vs. Okay, remember this formula, very, very important. Okay, after that what will happen that here, we'll go to the next page and see here, as we have got here F dash equal to F, and here what is this, V plus Vs by V minus Vs, is it? Now students, after that what is the value of the F dash? It is given here F plus 40, is it, is equal to F, and here we will put here the value, is it? And you can see very well students here, the speed of this sound V is not given, so I will take here the 330. Okay, nothing is given, that means 330. So see here this 330 plus 15, no, it is given here. After that 330 minus 15, is it? Now we have to calculate here the value of the F, is it? So see here, F plus 40 is equal to F, it will become here what, 345 by 315, is it? Now again let's simplify this further, this 40 will become here F 345 by 315, this F will go this side, it will become minus, that means minus 1, is it? That means students, it will come here how much here, 40 equal to F, take here the LCM and all that here, so 345 minus 315, okay, we can write here LCM na, by 315, is it? So after that students, what this will become here, it will become here, kindly see very well, this 40 is equal to, is it, F, and here what this will become here, kindly see very well, 345 minus 315, that means 330 by 315, 330 by 330, 345 minus 315, not 330, 30 only, is it? 30 only, is it? So after that students, what is the F? F, it will come here, see, 40 into 315, now cross multiplication by 30. So what will happen? This 0 and this 0 will cancel out. So 4 into 315 by 3, how much? We can write here students, see, 3 1 ja 3, anyhow 0 and 3 5 ja 15, is it? Then again multiply is there. So 4 5 ja 20 and 4 1 ja 4, how much is coming? 420 hertz. Kindly see very well students, here just calculations are there, is it? So this thing we have done. So what is the correct option? Option is not there anyhow, this is the any type question, so what is here? 420 hertz. So students, I hope so this video you have understood very well. Whenever the source and observer at the same place, like the car is there and it is moving towards the anyhow the vertical wall, so what we'll do here, we will just use here the mirror concept, this will become here the observer, this will become here the source, okay, and source to observer always positive, okay, and after that here this magnitudes will be there na, with the sign convention we will put the values and all that, and maximum to maximum situation this value will always come, okay, kindly remember that here, okay. So students, I hope so this video you have understood very well. Keep studying, keep growing.